Hey folks, Eric Wooldridge here of the Additive Guru channel. Today we're going to do a quick little demonstration on using Autodesk Fusion 360 Generative Design to make some kind of product, sort of a tutorial, but at least working towards something that might be useful one day. And let's just say, back in the day I used to do some skateboarding, and let's just say that I wanted to work on a new generative version of skateboard trucks. And if you're not familiar with what I'm talking about, it's a quick little Google search here that you can see. It's basically the component that mounts to the skateboard. So you see the 4 holes here to screw down, or 3 holes you can screw down into the skateboard. There, and on the back side. And then you would actually mount your wheels with their internal bearings right here. And so as you can see, this truck design is a very standard one. This one actually has some flexibility. As you can see down here, we won't worry about that for our example. What we're going to look at is, could we create this as a single unit using generative to maybe optimize this particular product. Now, it's not necessarily that we're going to be printing it in metal. We might just use some ABS or some other type of polymer for this application, but that's kind of what we're going for. When you look at the part itself, the basis of what we would need to design is obviously a cylinder right here to actually have a bolt that would come through and allow us to screw on. So this is a critical item. And of course, we'd have to have a copy of it over here, so critical item over here. And of course, we'd have to have a critical component of this. And we can probably just go ahead and say that we're going to have to keep the plate for our purposes. Now, the next thing we're going to have to consider is what are the forces associated with this. So what we would assume is that we're going to put a screw or bolt or something down through the 4 holes on the back side too, and that's going to be our fixed point. So we're going to consider that a fixed point of our design. And then we're going to have to consider that the loads that are applied to the wheels, the weight of the technically the force the earth exerts on the skateboard to keep it aloft, that being equal to the weight of the person, maybe times by a factor of 2, because of the fact that in the skateboards, they take a lot of beating. You're jumping, you're unlike me, performing an actual ollie, and you're actually getting some force generated. So we might take a person's weight, we'll say a person at 180 pounds, and we would multiply that by 2, make that 360 pounds is our target force. Now, that may or may not be distributed over all 4 wheels at once, depending on how you landed. It actually may be only on the back wheels. So we might consider this to be hitting both wheels at the same time, but not all 4 wheels of the skateboard. So we're going to have to consider there's going to be a force pushing down on whatever we design, and it's going to be equivalent to 180 pounds on each point. And these are just some rough numbers. Obviously we could play with this if we wanted to, but it just gives us something of a realistic sense of design. Now, how far apart is all this? Well, that is subject to a lot of different applications and choices. But what we can do is we can say that the plate's going to be somewhere around, we'll probably call it, the plate will be about a 40 millimeter one direction, maybe 55 millimeters the other direction. Mark that there for us. And just for our own purposes, we're going to say that this is going to be located at 150 millimeters. Each cylinder is going to be 150 millimeters from each other, and maybe it's going to be, I don't know, we'll say, get a measuring tape out here, we'll say about 70 millimeters above the plate. So we're looking at a plate of 40 by 55, 70 up, and then being sort of the center line of these cylinders that you see right here, and maybe the distance across can be 150. Again, we're not making an actual set of trucks here, we're just getting a concept design. So that's going to be our target for the application. So if you're going to follow along with this, you may want to take a screen capture and kind of put this off on the side of your screen to reference for later. That's actually what I'm doing. So there we go. So we have some rough numbers. We may end up changing that along the way. But let's go on into generative and see what happens. First thing I'm going to do is set up my game plan, how I want to design this. And I'll start off with the real easy part, and that's going to be the base plate. And as we said, about 40, we said about 55 that way, and about 40 this way. And I'm just hitting tab to jump between one side or the other in terms of the dimensions of that rectangle. And there it is. And then we'll come in and design our 4 holes. I'll place one right here and say it's going to be a diameter. Clicking on my dimension tool, clicking on my circle, we'll say diameter of 6. And then we'll click our dimension tool and hit the corner from here to here. And then we'll just say 7. And maybe from here to here. And 7 again. That should be fine. Again, not too worried about having it exact. Now I could go through and duplicate all this, but I can obviously use my mirror tool to take care of the rest. So I'll switch to my line tool, switch to my construction line, and of course if you don't see this little pop out here, you can hit a button to make it pop out. And I'm going to draw a line right here across where you see the triangle. That means that you're drawing across the midpoint of those lines. And I will use that to use my mirror tool to select this, then select my mirror line, click that one and say OK. Do it again, object here, this mirror line, whoops, sorry, try that again. This object, click on mirror line here to switch it over there, and there we go. That will give me the flexibility of changing things if I see fit. And a little trick that I'll do is I'll pull my dimensions way out. I might even make this hole just a little bit smaller, maybe 5.5. And maybe even give myself just a little bit more clearance and say 8 by 8. Okay. Alright, so finish sketch. And then of course we would be extruding this by hitting our extrude tool, selecting our zone, and for right now we'll just say a dimension of 7 millimeters, maybe 6 millimeters will be sufficient. Now obviously I could have gone through and added some nice little smooth features and that sort of thing. Actually that's not too hard, so let me go back and just do that while I'm thinking about it. Right click down here and say edit sketch, and then use your radius tool to click on this corner, that corner, that corner, and that corner. And we'll say it's not going to be that much of a radius, more like 4, just to round it off just a little bit. Well, maybe we can go 5, it looks a little bit better. Say finish sketch. Okay. And obviously we could go do some more rounding and smoothing if you wanted to, but that's not our major point here, so let's move on. The next step, of course, is picking out the location of these 2 cylinders. So my game plan here is to find a way to locate the cylinders in the center point of this and a certain height above. But what I created, I didn't create the plate in the middle of the origin. You can't see the origin there, but there it is. I didn't create it perfectly, so I can't use one of those features as a sketch plane. So what I'll do is I'll go construct a midplane between this plane and this one. Makes a nice one right there in the center. I say OK, and now I have something to utilize to draw on. So I'm going to hit new sketch. I'll select, if I can get to it, this plane, and now we're ready to draw our cylinder. So as we said, the cylinder is going to be up and over so far. So here's what I'm going to do. I'm going to go ahead and draw a line and say, you don't actually have to do this, you could actually locate it without too much problem. But I'm going to draw a line and say, find my point. Now, there's that origin of that. I come up, what do we say, 70? Enter. And we said 150 from one place to the other. Still such a construction line. So we'll say 75 this way. So that's roughly where I wanted to locate my cylinder. And we'll see if it looks okay. If it doesn't, we'll make some adjustments. But once that's done, I'm going to turn off my construction line and I'm going to design my actual cylinder. And so let's make a rectangle right here, and let's say it's going to be, well, that by that's fine. I can always hit this and say it's going to be 5 units thick in the wall, and I'm going to say 12 units thick this way. And I'm going to say that it's going to be maybe 3.5 millimeters up. All right, now what does this represent? This is going to be the cylinder that will be at the end of our truck, which we would put a bolt through. So just to give a little bit more thickness, maybe I'll go ahead and say it's going to be 15. And you'll notice that it kind of moved that way. That maybe not be what I want. So I'm going to do another trick by hitting undo, Control Z to undo that, and use another dimension to place this line. And we're going to say that it's going to be 1 unit there. And then I'll change this to 15, and it should kick it back that way instead of moving past my point. Another way that I could have dealt with it is line up dimensions to control it, but it's fine where it is. Okay, so another thing I'm looking at, I'm seeing, you know what, maybe 150 is a little bit too far, maybe 70 is a little bit too high there. So I'm going to change this down to maybe 60, and maybe we'll go 70 there. A little bit closer in. Okay, so now I'm ready to revolve my cylinder. And so I hit Finish Sketch, I say Revolve, click on that surface, select my axis, 360, and there we go. So there's the cylinder, which I intend on running a bolt through to actually attach my wheel. Now, I haven't checked to see what bolt size I would actually need to have here, but that's sort of something we could adjust later if we needed to. Now, of course, you understand that we need 2 of these, right? Need one on each side, so a quick little adjustment of that. You'll notice that I don't have any kind of thing to mirror across, so let's try this. Do another construction, mid-plane between this plane and that one. And now we have something hit OK to accept. And let's try the mirror tool right here, selecting this body. And say mirror plane this, and there we go. All right, now we have 2 features. Still don't really like how high that is, so I'm gonna go back into my sketch, right click here, and then maybe bring it down to 50. This feels a little bit better for me, so not so bad. Okay, so what we're shooting for now is this potential creation. You know, this is what we have to have. Now it's time for Generative to do the rest. So if you want to, go ahead and pause the video and go back and recreate what I've done. You've seen the dimensions, you may have taken a screen capture, make some adjustments, and do that now, please. All right. Next, it's time to start setting up our Generative Design. So I'll go ahead and switch over to Generative here. And there's the model. And obviously we've got some things to go ahead and to establish. First off, we want to tell it what we want to preserve. So I click on Preserve Geometry, hit the pencil button, select this object, and this object. And okay, so now preserved. But next comes the real challenge, and that is making sure that we don't interfere with things that we have to actually attach to the skateboard. So that's our obstacle geometry, but we have no obstacles to work with, so I'm going to go to Edit Model here, go back into our sketching situation, and say, let's create a sketch. Actually, we could actually do a connector obstacle. And we can come down here, click on that, tell it to be this way, and select some more. I missed, let's try that again. Connector obstacle. That, back to it, that one. Looks like it's only going to let me do one as I go along, so that's fine. Okay. And that works. Hit OK. So this allows me to create a feature like that that's going to be an obstacle. Now, could I have done it as an extrusion? Absolutely. I could have just said extrude in there. Except I would change my profile to be, let's see if I can get it here. And it's gonna want to do it the other way. I might just do it this way by saying sketch. Click here, finish sketch, extrude. There we go, got it that time. There, there, and there. Because we're doing something very, very simple, I'm not going to get too tore up with making it just perfect. We can always make them a little bit larger if we want to. And I could have changed the size of my connector, but we'll just assume that we can get our objects down through this. If I wanted to be really, really careful, what I would do is I'd make these holes just a little bit larger, or actually use my connector obstacle tool to make sure that my openings with the top of the head of the screws wouldn't be interfered with. But for our purposes right now, this is okay. So I say make sure it sits the new body, and I hit OK. I'll finish edit model, and I'll come back into obstacle geometry, click on my pencil, select this one, this one, this one, and this one, and say OK. They go red, and I now have zones to avoid when it does generative. The next thing I have to worry about is the fact that there's going to be some bolts on that and going that way. So let's see what we can do. We'll go back into edit model. And this time I'm going to be a little bit more cautious. I'll go ahead and use my connector obstacle, zoom in real close, click on the circle, and you see that it's popped out, and that's fine. I will turn on the bolt head. You'll notice that no bolt head appears because it's going this way, so I tell it to flip side, and there's the bolt head. Not too concerned about how it's going to fit. I should probably pull it in just a little bit. Let's see, 5. I'm sorry, let's leave that at 10's fine. We'll just reduce the shaft length down to 5. So we're going to leave space for this to get in place. I should probably do a little bit closer, but I think we'll be okay. We can always drill a little bit if we absolutely needed to. So it's in place, and I'm fine with it kind of as it is. I could even take it down to 1 if I wanted to, just to make sure we're covered, and we should have enough size for the bolt head. If I need a more head diameter, I could set to 12, and we should be clear this way, and I can even pull it on out. Now what I can also do is make sure that I can easily get this into place if I want to drag it all the way across. Whoops. I could drag it all the way across to this feature, and it would obstruct the whole thing. But the problem is I may need this space in between, obviously, to work, so I'm not going to get too crazy. Just maybe 35 would be long enough for me to find a space to get it into and slide it this way, and so we would be good there. And I'll just simply repeat the process over here. A person could just go ahead and say that we're going to use this as our value and just pull it this way and say 35, and that too would probably work out just fine. Well, I'll try both. Let's see what Fusion does. Finish edit model, and as you can see, it's automatically put them into geometry to avoid. Okay, why don't you go ahead and pause the video and catch up to where I am. Okay. So next, of course, there is the basis of what we're after, and that is the generative design and the loads. So let's set up some design conditions. I'll click on structural constraints, and I will say that this surface here is, actually it would technically be the screws. So I'm going to say that the screw hole there, 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 and there is fixed. And that's the only thing that's going to be fixed in this scenario. Next, of course, is the loads. Alright. And our force is going to be applied, essentially from the bolts themselves. So I'm going to apply it here and here. And then we're going to apply the force. Now we're just going to assume this is a completely vertical. So I'm going to set it to be a vector. And that just means the force is coming in a certain direction. And I'm going to set the vector, let's go for a Z and see which way that is. See if that's going to show up the way we want to. No, looks like that's not going to be the right one. Let's try 10 here. Sometimes I don't pay attention to my directions. There it is. Okay, so it's going to be forced up, and technically I'm going to be going in a negative value. Now, rule of thumb, I usually, technically the Newton is about 4.44 or something like that. I usually just say 4.5. So 180 pounds times 4.5, what is that, around 100 or 800, 810, something like that. So we'll say 810. And the force is pushing down on our geometry. So now we have loads applied. The base plate is fixed. We have our obstructions that should allow us to get the screws in where we want them to be. Chances are these are not going to be large enough, but we're going to let it ride and just see what happens. And of course we have to select some other things, for example our design. And we want to minimize mass or maximize stiffness. Let's just go ahead and say minimize mass, but let's say a safety factor of 2 just to be even better. And then of course we have to select our manufacturing method. We're going to use additive to produce this. Obviously there's other things that could be done, but we're going to use additive here. We might even go ahead and say that the minimum thickness is going to be a little bit larger than that, maybe 3.5. So we've set that up. Now of course we have to select materials. The default material that they have set for us is aluminum, which is, we're going to try something wild and crazy. We're just going to try some more plastic-based materials. So I'm going to slide down here into plastic, and I may say, we can always choose ABS, but we've got polycarbonates. So I might slide down to, say, PC ABS. So I'll grab it, drag it up, and there it is, steady. And we don't really want to do aluminum. We don't want to have, the more materials you have on here, the more generations it's going to do. So I don't really want that. So I'm going to click on this one and then just right click and say delete. And then there is our ABS plastic. Now, there's no way of telling for sure right off the bat that this design is even going to work. It might just be too much for the design to actually take advantage of. And that's okay. We can always come back and make some adjustments. So I close. And so we have set up, we see our check here, pre-check's good, and we hit generate. Now notice that I'm doing the generate that's preview generate, not the actual generate. Let's see what it does. All right, now, hopefully you can see one mistake that I made, and that is that I forgot that to account for the fact that the hole can't go through that, and I don't even think I made it set so that the hole couldn't go through that too. So I need to fix that real quick. So this is why we do the preview generate, so that we can take care of that. So I'm going to quickly hit edit model, and I'm going to add in some more obstructions. And just to save time, we'll just pause the video and show you what I'm going to do. Okay, so what I did was I actually turned off a couple of my bodies. I hit the expansion option here with the model components, turned off a couple of those connector bodies that I couldn't see at the moment. And I actually just did a sketch on each side and sketched out 2 really large cylinders to make sure it was clear. The only thing I should probably also do is make sure that it doesn't extrude anything into the holes. But to be honest, if it does, we would just drill it out. So I'll just leave it right now. If I want to be really careful, I would actually design something through there. But for the moment, it's okay. Again, we're always learning and testing as we go along. So anyway, I turn my features back on. And you can always create those real quickly. Make them nice and large so it definitely can't get around those. Switch to my obstacle geometry, and I obviously want that and that to be obstacles. One thing I will point out when I did that edit model is that I made sure when I extruded those I didn't tell them to be a join, but I told them to be a new body. Alright, so now I would hit generate again to preview it. We'll see what it does. Alright, that looks better. We can see that it's kind of warped around there. Again, we see that we've got some work to do down here because with obstructions. So back into edit model. And I'm going to do some quick extrusions. Let's see if I can extrude here, hit that feature, that feature, that feature, and that feature. Pull them out as new bodies. Hit OK. Just thinking about it, there we go. And then of course I need to make sure I put something way down here so we don't get any extrusions as well. And just to be on the safe side, actually I'm going to do a sketch and make one big feature. Just so it doesn't get confused that it can't put anything down there. So nice big rectangle. I hit extrude right there, and of course there too. Pull it out and new body. And hit OK. Back to my main. I'll turn off my preserve geometry. And I need to make sure that I set all of this to be obstacle. That, and that, and that, and that, and that. And we should be good now. Alright. Turn preserve geometry back on. So now it knows it can't get into that zone, and hit generate preview one more time. Okay, as you can see, it is now gotten itself where it's not going to get into those zones, but what you can see is the problem though, in my situation is that I have no way to get the bolts down in here to push through to the cylinders. So I'm going to need to do something to create a pathway to get down into that so I can even place the bolt the way I wanted to. So let's hop back into Edit Model one more time. And we're going to have to do something in that area so that we can actually make sure that we get down into there. So what I'll do is a little trick of just saying I'm going to sketch on this surface, right? And I'm going to turn my visual style to wireframe so I can see some things. And of course I'm going to kind of orbit around until I can make sure what I'm looking at is supposed to be what I'm looking at. Alright, good. And I'm just going to do this. Draw a rectangle about yay big. Actually, draw a rectangle about here, about yay big, and just drag it straight up. This will give me a path down into my object. Alright, finish sketch, and extrude it, and all of it, of course, and bring it this way, about the same length, and it's going to be a new body. Okay, and I would just repeat the same thing. In fact, I can probably just mirror it. I believe I can do a mirror. Yeah, mirror this feature right here along our original plane right there, and there we go. So pull back out of that and tell that to also be obstruction. Does look like it has. There we go. So now we have a pathway to get things down into. Generate one more time, preview. Alright, you can see it's formed up a little bit. And hopefully you're getting a feel for the fact that you do have to do this kind of thing a lot. You have to really think through what is going to be, needs to be open just to get parts in and out. And we had to create all of that so I could slip a bolt back down into here to actually allow a screw or an actual wheel to attach to. So there's a concept that looks like it's doable. Again, my screw holes here are probably not the right size, probably need to make them bigger, but it's enough for us right now. And go ahead and pause the video, maybe add in some of those extra things that I've done, those extra obstacles, and let's get ready to generate this. Pause the video and do that now, please. Alright, so here we go. I'm going to go ahead and hit generate, and it says, do you want to continue? That's fine. Check to make sure we've got the credits. We do. And tell it to generate the study. And I probably need to save it. So I'll say skateboard truck. Save. And it starts its operations. So we'll pause the video and see what happens. You know, as I mentioned, this may not work because we're dealing with a plastic versus typically a metal object. So this may be a little bit tougher than polycarbonate or even ABS could handle in this situation. So it may calls for readjusting, but at least this is a good starting point for us to decide. Now, we could be thinking using metal 3D printing to do that, but whenever we can start off with a polymer-based outcome, that's always better because it's more sustainable to do that with polymers than typically metal. Okay, so we'll let it run, see what happens. Alright, so we can see that we have 3 converged studies, several different variations. Let's take a look. You can see right here, this one made it work pretty well. Have the space to actually attach the bolts from both sides, and of course get the bolts down through the part there. Kind of a unique design, not exactly symmetrical, but pretty interesting. We can track back, see as it filled it up a little bit. Sort of a thicker version there. Alright. So take a look at the other one. Compare them together. We got our first study, second study. Kind of similar in results. Take a look at our third one. This one had a unique variation to it. A lot more of the branching off that you see there. Kind of interesting, really created some odd pathways to the lower plate bolts. And it did look like I didn't go all the way through on my boundary or obstructions right there. So that would have to be drilled out. Or I can just go back in the model and kind of correct that problem. Slide it back a little bit, see how it formed it. Yeah, not liking that one so much. Let's take a look at the history of iterations on the number 2 there. And that one's pretty interesting to begin with. Again, see that I should have gone ahead and made sure I went through all the way through on the cylinders for my obstruction. But pretty neat creation overall. So take some time to go ahead and generate your results. See what you come up with, see if it's slightly different, and you can choose which one you like the best and which one you think would be the best fit for you. And of course, you can always go back and make changes to your original design, going back in and fixing the obstruction, so there's an obstruction all the way through the holes on both sides would be good. It also seems like our plate could probably be a little bit thinner and could be optimized a little bit more. Of course, once we select which one we're most interested in, and by the way, you can check out that preview. You can slide the slider and kind of see how it grew it or melted it almost. And whichever outcome you find is the most preferable for yours, you can always go through. I like this one a lot, I believe. You might choose it about right there. And of course, when the choice, when you figure out which one you like the most, then you can actually export out to an STL or take it back into the design and work on it from there as a parametric model. I'll just go ahead and demonstrate the mesh option and just hit your export, and it analyzes and tells it to create a new mesh design. Of course, noting that the actual exported mesh will be at the iteration chosen at the time I hit the export. So if I was at 41, it would have been that final. I did mine at iteration 31. Now while it's preparing, I'll make a couple comments on my design. One of the things that would make my design more realistic is, if you remember, we set the loads primarily as force loads, and it was all in a vertical direction. But in any kind of skateboarding situation, when you're rolling along and you do have a downward force on the back of the wheels, you're likely to have some type of horizontal force as well associated with impact, or even just crashing out. So we probably should have applied some type of horizontal force as well into our design to create a little bit more realism in our analysis, which we can always go back into our generative design analysis and apply those. So that would be something that we could go on and play with a little bit more to improve our process. Another thing is this was on the first study. I kind of like it as well, especially the horizontal ribs that you see right here. These are real good for resisting the lateral motion that would be realistic, even though we didn't actually build it into the design. So I kind of like this one. This one was pulled back to about 29 iterations, and of course you see there's missing in the hole. Again, the fact that I didn't do my obstructions very well and punch it all the way through, but we could easily correct that going back in the design and fixing that. So I like this design a lot just because of that branching of those ribs, and we see that reinforcement there. So I think this would be a pretty strong design, pretty strong contender as well. Alright, looks like our mesh on this one is ready. So let's hit that check mark and we'll open the mesh design. And here we are. Now this one can probably be better viewed as a shaded style. Handy little trick, if you just hit Control 4 on your keypad, and you can see these keys, or these shortcut keys. So quick Control 4 gives us a shaded view, which is a little bit easier to visualize. And here we could actually have a mesh that we could turn around and manipulate as a mesh, or we could go ahead and go through the process of exporting it out. You'll notice that it is one mesh body, and we could actually go through the process of 3D printing it, saving it as an STL or as an object file for printing. Alright, so that's the overall process. Hopefully you got some good results out of that for yourself. I'd go back in and fix the boundary, or I'm sorry, I keep saying the wrong term, the obstruction by punching through those 2 points there and there. I could take care of that in this model if I wanted to, but it would probably just be easier doing it in the generative stage just to make it right. And hopefully you got some good stuff to work with. So you can create it, export it as an STL, and then get to printing as well. So thanks for watching, and check out some of our other videos. You might find something useful and handy. We'll see you.